Good afternoon or good morning to you West Coasters, and welcome to Food Processing's webinar, Are Your Cleaning Tools Hygienically Designed? I'm Lauren Hartman, Product Development Editor at Food Processing Magazine. Today we will be talking about food safety and hygiene in the plant. There's probably no more critical issue in the food and beverage industry today. While most companies have amped up their efforts at keeping a clean and sanitized plant, they may be undermining their own processes by not paying as close attention to the tools they employ in those efforts. Specifically, the cleaning tools and brushes employees use to clean the equipment. Instead of contributing to the sanitizing effort, poorly designed brushes and cleaning tools can actually introduce and spread around bacteria and other contaminants. To show you some very graphic examples of harborage in tools and to school you on what a properly designed cleaning tool is, here is Deb Smith, Global Hygiene Specialist at Vikan. Vikan cleaning tools are represented in the United States by Remco Products.
Hi everybody, and thank you for joining us for this live webcast. I have to say I've done many presentations, but this is my first using a webcast, so fingers crossed it all goes well. We're going to start really with a question for you. Make sure you're all awake, and I'd like you to think about this question and respond as appropriate. Do you currently use cleaning tools that are of good hygienic design? Now, you probably, well, hopefully you already know. If you don't already know, you might want to think about that and then respond accordingly. I can see a few of you have already responded. I've got some good feedback in terms of yeses, which is always encouraging. We'll just give a little bit of time for people to find the buttons and click the answers. It's still looking very good, guys. You're pretty much on the yeses at the moment. And it's going up and up. The good thing is that for those of you that might not be aware of what hygienic design are, by the time we finish this presentation, you should have a much better idea. But actually, I can see from the responses I've had so far, I may be talking to the converted. Right, I think we're getting to the point where we've got some good results. So let me just move on, and then we can actually show you the results of the poll. So there you can see that 53% of you responded yes, that you do currently use cleaning tools that are of good hygienic design. 41% of you are not sure. Well, in that case, listen on and we'll try to give you some more information. And for those of you that said no, 6%, then there's obviously some awareness of hygienic design and the fact that the equipment you're using isn't appropriate at the moment. Okay, well, let's move on. Just going to give you a brief introduction as to who Vikan are, mainly because we're European-based, so you may not have heard of us other than through Remco in the US. We are manufacturers of manual cleaning equipment. We were established a very long time ago, very, very long time ago if you're in America, in a place called Skive, not Skies, in Denmark. And there should be a little map that appears on your screen to show you exactly where we are, and a picture of the actual plant itself. We have about 250 employees and worldwide sales with a turnover in excess of 40 million euros. And we're actually owned by a charitable foundation, which means that the majority of the profits that are made by the business actually go back into supporting, not sustaining the business, but also supporting medical and technical research. As for myself, my name's Deb Smith. Lauren gave you a very good introduction. I'm a microbiologist by training, and food microbiology in particular. I have over 30 years of food safety and research experience with qualifications as appropriate. Most recently, I've just qualified as an FSSC 22000 auditor. I've worked in the food industry for a large poultry manufacturer and then for the UK government as a food safety researcher, and then at an establishment called Camden BRI as their research manager in the food hygiene department, before moving on to work with Vikan as their global hygiene specialist for the last 5 years. I do presentations, as I mentioned, all over the place, and I'm really there to support the food industry, to provide advice and training. One of the key roles I have within the UK is as a member of EHEDG. For those of you that don't know who EHEDG are, I'll explain that a bit more as we go on. So, a bit more about EHEDG. EHEDG are the European Hygienic Engineering Design Group. They are a European-based group of volunteers from academia, research, food industry that come together to pool their knowledge and experience and provide guidance to the food industry on the hygienic design of food production equipment. Those of you in the US will be more familiar with 3A. 3A are actually the older established organisation with regard to hygienic design, and EHEDG are the European version. Both provide guidance to the food industry on hygienic design. So then, EHEDG certainly is an independent not-for-profit organisation with the academic and industry volunteers, and as I say, the primary role is the promotion of safe food by improving hygienic engineering and design in all aspects of food manufacture. They do that through production of guidance documents, training courses, and certification for certain parts of the equipment that they monitor. But so far to date, their focus has been on the food production equipment rather than anything else. And that's where Vikan has been pioneering some further investigations. Now, we've got another polling question for you here, and we'd like you to estimate now which attribute is most important when choosing tools for your sanitation program. Is it cost? Is it durability? Is it cleanability? Or is it the fact that it might be purpose-built? Again, you'll probably need some time to think about that one, so if you can think about your own applications, the things that happen in your site, your manufacturing plant, the things that are important not only to you, but maybe to the staff using the equipment, maybe even to your purchaser. I'm sure you all have different views on what's most important. I think when you have 4 options, it makes it even more tricky to decide which is the most important out of the 4, but we're getting some good mixtures of answers here. And at least I know you've all found the buttons now, because you're responding well. Okay, I think we've got most people's responses now, so let's have a look at the results of that poll. So here, I'm very pleased to say that a lot of you are thinking about cleanability, which is actually hygienic design. That fits in well with the theme of the presentation. Purpose-built, that's very interesting, because we're finding more and more that when we speak to end users, they do have bespoke requirements for their equipment, and that is obviously a key factor for them. Cost is, as usual, a significant consideration, but I'm glad to see that it's not outweighing the cleanability or the requirement for bespoke equipment. And then we have 5% on durability. That's great. Thank you very much, guys. Okay, so hygienic design. I'm glad to see from your responses so far that most of you will have an awareness of hygienic design, but for those of you that don't, or those of you that would like to know more, what does it mean? Well, there are a number of terms you may come across when you're talking about hygienic design. Really, it's about how easy it is to clean something, or sometimes called cleanability, or the ability to clean something easily. And really there are 2 things to consider when you're thinking about hygienic design. The first being the actual construction of the equipment and the way it's made to make it hygienically designed. And the second is the materials of construction. So we'll be looking at both of those aspects as we go through the presentation. So the benefits of using equipment of good hygienic design are numerous, and I've listed them here, or some of them here. They're not in any particular order, but I'm sure a lot of these will make common sense to most of you. They're quicker and easier to clean. They minimise the risk of product cross-contamination, be that from bacteria, allergens, foreign bodies, or food residues, even chemical residues. They maximise food safety and quality basically because they reduce that risk of cross-contamination. They also reduce the risk of expensive product reject and recall and minimise food waste. These are very big topics for the food industry at the moment and areas which they are keen to reduce. Ultimately, because of all of those things, there are cost benefits involved with hygienic design, and that's something that is more of a long-term benefit and is worthy of consideration when we're talking to purchasers. So, in specific relation to cleaning equipment, there's a few things here that you might not know about cleaning equipment that I thought was very interesting that I want to share with you. The first is that there was a study that was done which showed that cleaning equipment has been shown to be a major source and vector of cross-contamination. Now, this was a study that was done by Camden BRI in conjunction with the Ministry of Agriculture, Fisheries and Food, as it was in the UK, it's now DEFRA, that showed that 47% of cleaning equipment that was tested was positive for the pathogenic organism Listeria. Now, that was quite a shock because they also tested things like the floors and the drains where they were anticipating seeing relatively high levels of Listeria, and actually they only found about half of the amount of drains that they tested compared with cleaning equipment was contaminated. ISO standards, and really here I'm talking about the new Food Safety System Certification 22000. Within that standard there is a section of ISO which is the TS 22002, which relates to prerequisite programs on food safety, and within that standard it states that for cleaning and sanitation agents and tools and equipment shall be of hygienic design. So here we have what is fast becoming the largest globally recognised food safety standard, stating that cleaning tools should be of good hygienic design. Now the BRC, the British Retail Consortium, in their Global Food Standard back in 2015 also newly stated that cleaning equipment should be hygienically designed. So that prompted us to really do some investigations with regard to the hygienic design of cleaning equipment. Unfortunately, there is very little guidance on the hygienic design of cleaning equipment, and very few cleaning equipment manufacturers produce hygienically designed tools. So here we are, the end user is faced by the demands of two global standards for food safety with very little guidance to go on as to how to react. So we thought we should try to improve that situation by doing our own investigations. Okay, so another polling question now for you. Does your sanitation program utilise colour coding to limit cross-contamination or cross-contact in your food production environment? I'm sure many of you will already be familiar with colour coding within your food factory environment. It is a very well recognised, very well established method of controlling cross-contamination. So I'm expecting a fairly high response on the yeses here. And it's looking like it's going that way, which is reassuring. Okay, interesting results on this one, I think. When I share these with you, which will be pretty soon, I think you've got here. Okay, let's share those results with you. So we've got 70% saying yes, which is great because, again, as I said, it's a very well-established, useful method of containing your cross-contamination. And 15% with no and 15% with not sure. So there we go, interesting responses. Okay, so moving on, I said we were going to try to look at the issues within hygienic design of cleaning equipment, and we focused mainly on brushware. We did investigate other types of equipment, but we've focused on the brushware study for this webinar presentation. And what we did, we investigated different types of brushware construction. The most common one is the drilled and stapled brushware, which has been around for many years, where you have a solid block of plastic, you drill a hole in, and then you fix the bristles in with a metal staple. You then got resin set brushware, where you have a hollowed out block where you put the bristles in place and you pour usually a 2-part epoxy resin in to set the bristles into place. There's the resin set drilled and stapled, I should say drilled, not drilled, where you're using resin and staples to fix the bristles, and then a production method using fused filaments. So we'll have a look at each of those. We used a number of different assessment methods, including visual inspection. This is probably the most commonly used and obvious and useful one to start with. Then we looked at some of the equipment under a light microscope. We have a small lab in our department at Denmark, but we also utilised an electron microscope, which was actually an independent test lab in the UK. We also used this UV gel. Now you may have seen this used or may be familiar with this with regard to hand hygiene. So the idea is that you put it onto people's hands, they rub it in and it kind of disappears. They then wash their hands in a prescribed way according to each site, and then they look at their hands again under a light box, and under the UV light, any of the UV gel that they've missed in the cleaning process shows up under the UV light, and it's used as a hand hygiene training aid. You can see this is the gel as it comes out of the bottle as you see it under UV light, and then the box is the UV box that you put your hands in after you've done the washing. So that's, we've used that technique to identify areas that haven't been cleaned properly on the brushware. We also used this small pot of soil. This is a red powder, which is a protein soil, which you can mix with water to make a paste, and it's used by the health service in the UK to validate the cleaning of surgical equipment in hospitals. So it's another useful technique for identifying areas of equipment that aren't properly cleaned. And then finally, in the bottom corner there, we have a thing called a surface profilometer. Now that actually measures the surface roughness of a surface using a diamond tip stylus, which is the little protrusion you can see at the bottom of the machine. So we did some measurements using that. These are some pictures of the drilled and stapled brushware. Firstly, you have just a visual inspection in the top left-hand corner, then an inspection closely where the bristles go into the brush stock using a light microscope, and you can start to see a few of the areas where there could be contamination that gets trapped. If you look at that area under a higher magnification using the electron microscope, you can certainly see there's gaps around the base of the bristles where they enter the brush stock, where contamination can be. And in the final picture, if you cut down through the bristle bundle, obviously you've got the gaps between the bristles going down into the hole of the brush. Now to investigate those further, we took that UV gel and we took a drilled and stapled brush, and we liberally coated the brush in the UV gel, and we worked the UV gel into the areas that we knew there could potentially be an issue with contamination being trapped. until you've got a fairly well-soiled brush. And if you look at that then under the UV light, you can actually see the contamination. Shows up at this kind of bright white-blue contamination. We then proceeded to decontaminate the brush, and we chose a minimum decontamination technique. This is a technique you see used in food factories quite a lot, where you just have a bucket of warm soapy water and you just dunk the brush in and out until it's visually clean. So that's what we did. We did standardise the temperature of the water and the volume of detergent and the amount of dunking, so that we could do direct comparisons between all of the samples we looked at. And then we examined the brush again under the UV box. So what you can see in this picture is the UV gel that's not been removed during the washing process, mainly situated around the hole edges where the bristles enter the brush stock. Really no real surprise. I think common sense would have told us that, and we had already thought about that. If you cut down through the brush itself, you can see the lining of the hole where the bristles sit is also still contaminated. So you've got the blue, white, bright colouring there of the UV gel that's been trapped within that hole. So that's really, those are areas that are key when considering hygienic design. The idea is to eliminate those kind of areas within any construction so you don't get somewhere where contamination can be trapped. We then moved on to take a look at the resin set brushes. And again, this is a picture of a brush just through visual inspection. Going closer so you can actually see where the bristles enter the glue within the recess in the block. And then if you cut down through the block, you can see the way that the bristles are actually set into the resin. You can also see a fairly deep recess between the top surface of the brush and the level of the resin within the brush block. Again, we applied the UV gel, and then we looked at the contamination that remained after cleaning. So here you can see the bright blue-white contamination left at the ridges on the brush, and then deep set within the recess of the brush where the bristles go into the resin. And also in the configuration of the way that the bristles are looped within the resin. They're kind of looped and twisted, and because of that, you get an area within the loop of bristles that gets protected from cleaning and where contamination can get trapped. The next brush we investigated was actually, this is an American food industry product brush utilising fused bristle technology. And again, we looked at this under different levels of microscopy and again with UV gel. So you can see, I think again, even before we use the UV gel, you can see the areas within the brush where the UV contamination is likely to get trapped and not be removed after cleaning. And that shows very obviously what's happening. The other thing that this brush had was a very rough surface finish. So the material that the brush is made of is a foamed plastic, and that leads to a very wrinkled surface, a very rough surface. And when we investigated that with regard to the UV gel, we found that a lot of the contamination was getting trapped. It was very, very difficult to remove. Now you can actually measure the surface finish of something using that surface profilometer that I talked about by dragging the diamond stylus across the surface and getting a measure of the roughness. And then the data is calculated into an average surface roughness, which is known as RA. The EHEDG do have a recommended RA value. Anything less than 0.8 microns is deemed cleanable. Then moving on to the resin and drilled and stapled products, these are considered or were considered, I should say, one of the most hygienic options on the market at the time. So they were obviously very worthy of consideration. Again, you can see a visual inspection of the brush at the top, and then a light microscope image of the way that the bristles go into the resin. The idea is that the resin seals around the bristles to prevent any holes and crevices forming, and from the initial pictures we could see that that was doing its job. And even when we took it to the next level, at the electron microscope level, you can see the resin sealing around the bristles on the outside of the bundle and doing the job that they claim to do. What I then did was actually cut through the bundle at a right angle, and we have a picture here where you can see that the resin seals around the bristles on the outside of the bundle, but it doesn't actually penetrate into the center of the bundle. So those bristles in the center are not surrounded by resin, and there is no seal there as they are on the outside. That's actually even more obvious when you cut down through the bundle, and you can actually see the channel that develops. So here you've got a cut through of the bundle down. You can see the resin sealing around the bristles on the outside, but you've got this channel in the middle, and that's a very deep, very narrow channel where contamination, be it microbes, allergens, can accumulate and then be very, very difficult to remove. That image showed us the principle, but we really wanted to take that a step further and actually see whether it was possible for contamination to get trapped and not be removed. So we then turned to the protein soil that is used for the assessment of equipment in the health service, and we took that, we reconstituted it and used that as the soil on the brush. This is the bright red that you can see on the product here. You then leave it to dry for a couple of hours at room temperature. There's a prescribed protocol that you have to follow, and then we put it into an industrial dishwasher. Now, this industrial dishwasher was being used by a food industry company, and we followed the procedure that they use. We had exactly the same model of machine, the same detergent, the same cycles in terms of rinsing and temperatures to put it through the process. And what we saw when we took the brush out after it had been washed and cut down through the brush again was that you still got the red protein soil trapped within the bundle in the crevices, the channel that we saw previously. So that's after a very rigorous wash procedure as opposed to the bucket wash procedure. Contamination is still trapped within the bundle. Okay, the other thing I mentioned at the beginning of the presentation was about the materials of construction. So far we've focused on the actual construction design and trying to highlight where contamination can be trapped. The other thing to consider is this materials of construction, and the EHEDG, and I'm sure 3A as well, there are a number of criteria that it must meet in terms of materials. First and foremost is that it must be made of materials that are food contact approved, whether that be through the EU in Europe or the FDA within America. The material should also be durable, non-foamed, not painted or coated, because those things can chip and break and cause a foreign body risk in the product. Non-absorbent, because once stuff gets absorbed into a product, it can then harbour bacteria deep within the product and come back out again. And be appropriately temperature and chemical resistant. With regard to EU and FDA approvals, the EEC regulation that applies to food contact materials is the 10/2011 and 1935/2004, and those stipulate that we must conduct a thing called a migration test and then issue a declaration of compliance to show that the product or the material is food contact compliant. Now, for the FDA, I know things are changing at the moment because of FSMA, but up until recently it's been the CFR 21 regulation that covers something similar within the American food safety legislation. I'm going to quickly take you through the migration test because, again, I've heard various people talking about changes within FSMA and the possible adoption of the European style migration tests for new materials of construction for food industry. So to show you what we do in Europe, really it's a matter of gathering all of the information about the raw materials that we're going to use in the product, whether that's the plastics, the plasticizers, the colorants, scrutinising all of that information in conjunction with the EU legislation to make sure that it all complies. Then you actually, if all of those boxes are ticked, you actually make the product, and then the product goes to an independent accredited test lab who actually put the product into different types of food materials. So they'll submerge the product in olive oil or in ethanol or acetic acid, whatever's appropriate for that particular product, and they will leave it in contact with that food for a set period of time, at a set temperature, and then after that time they will analyse the food product, i.e. the olive oil or the ethanol or the acetic acid, to see if anything has migrated from the plastic into the food, and that's why it's called a migration test. The results of the migration test are then issued as a test certificate, which is sent to the manufacturer of the equipment, in this case Vikan, and we then issue an EU-compliant declaration of compliance, which is available for our customers to use to show to auditors to show that they have equipment which is of appropriate construction materials. As I mentioned, the tests must be carried out by an independent accredited test lab so that there is no bias from the manufacturer. So in terms of responsibility for materials of construction, it is the responsibility of the manufacturer, i.e. Vikan, to have the migration test certificates issued, to have the appropriate testing done, and then to issue the declaration of compliance. And for our customers within the EU, really it's so that they can ensure that they have that documentation available for auditors, or if they do have to go to court for any reason and defend the choice of equipment that they've taken into the factory, that they have the evidence to show that it is appropriate. So we encourage people who purchase our equipment to also ask for the documentation that goes alongside it so that they have that to hand if they were to need it. With regard to the FDA, you have a slightly different system at the moment. As I say, things may change because of FSMA, but you have a list of restricted substances, and if none of those are present within the raw materials, then the product is approved for FDA or by FDA. Unfortunately, that doesn't really take into account what happens when you mix the raw materials, whether there's a third material that is produced as part of the production process. It also doesn't really take into consideration whether there's any reaction of the product with the food once it comes into contact. So I think that's some of the reason behind the proposed changes for the testing to maybe fall more in line with some of the EU style testing that we do. So if any of you out there, after we finish the webinar, do have any more up-to-date information about how the FSMA regulations are shaping up on this, it would be great to exchange that information. So let's talk about improved hygienic design and application of some of the EHEDG hygienic design principles to future cleaning equipment development. So we're really looking to get rid of all those things that we've highlighted through the studies, get rid of crevices, contamination traps, have a smooth surface finish, something that's easy to clean and dry, food-safe materials, well-constructed, durable, non-absorbent, and temperature and chemical resistant. And really that's where we developed the new UST ultra-safe technology brushware. And we've got a product here which is of a fully moulded construction, so we're trying to eliminate as many of those cracks and crevices and holes as possible. We've also got a unique bristle retention system which reduces the risk of foreign bodies, which I'll explain in a moment. We're getting rid of resin. We've got no metal staples and, as I say, reduced risk of bristle loss. No drilled holes, which is a fairly unique feature. No sharp internal angles where stuff can get trapped. We've got a smooth surface finish, which is actually less than 0.8 microns. And all of those things make the product much easier to clean and dry. They are also made entirely of food contact approved materials. One of the things we also found as part of our investigations of resin set products was that some of the resins used were not actually food contact compliant, and it actually stated this in the company's declarations of compliance, as well as some testing that we had done ourselves. They're fully coloured, and we have full testing and documentation available to support the claims. So I just want to talk to you about, in detail more about some of the construction principles behind what we've got. I'm hoping it's going to load up. There we go. It's a little bit slow because it's an animation, so I think it might take a little while. Okay, so here's a representation of a drilled and stapled block product. You've got the block in blue, the hole that's in the middle is drilled, then the bristles are fixed by a staple in the middle. And then similarly for the resin set product, the dark blue that's around is representative of the resin, but still with the channel in the middle. Now once you make a brush like this, the bristles are very secure within the block held by the staple. But as soon as you pull one of the bristles out from underneath that staple, you create a gap which makes the others looser. And then the more bristles that come out, the looser the bundle becomes, and the more risk there is of more bristles coming out. And that applies both for the drilled and stapled product and for the drilled and stapled resin product. The UST product has bristles that are individually fixed, so each one is moulded within the block, and that means that if one of them does get pulled out or break, it doesn't affect the security of the rest within the bundle. You can still pull the bristles out and break them. At their thinnest, they're only 0.23 millimeters thick plastic. So if you put that up against a piece of stainless steel, they're gonna lose. But what I'm saying really is that if you do break one of them, or one of them does pull out, it doesn't increase the risk of others falling out, as in the other previous products. Oh, gosh, I think we've missed a slide there. Let's try this one. So this is the cleanability slide. So just to go through that, again, it's an animation, so it might take a few minutes just to get going. No, it doesn't want to play. Oh, that's a shame. No. Sorry guys, I'll just see if I can get that slide to load up, but it doesn't seem to want to play. Oh, there we go. Decided to play ball. Okay, so what we have here is a small animation of a drilled and stapled brush. You've got the green contamination within the hole of the brush, and the orange or red that's going across is the water that causes turbulence as it goes across the surface of the brush to clean. Now it's the turbulence that actually does the removal of the soil, and the turbulence is only really created at the interface between the block and the water, which only penetrates 1 or 2 millimeters down. Obviously not deep enough to actually get to the deep recesses where the food soil is trapped within a drilled and stapled brush. The same thing is true for a resin set brush within that channel. But for the UST brush, we do have a slight recess. It is 1 to 2 millimeters deep, but because that turbulence actually is generated at that interface, there is more likelihood that more of the soil will be removed as the brush is cleaned. I'm glad I managed to get that picture going for you. So we went through the bristle fixation, that's good, and it comes pretty much to our last slide. So the future. What we would like to see is the incorporation of hygienic design principles into other food industry cleaning and equipment designs. not just brushware, but squeegees and scrapers, scoops, all sorts of things. And maybe for there to be guidance and standards and certification, training on food industry cleaning equipment so that food manufacturers can comply with the standard requirements. And maybe the formation of an EHEDG or a 3A subgroup on the topic. And maybe someday all cleaning tools will be made this way. We're very fortunate in that since we launched the USG product, we won a couple of industry awards. So you don't just have to take our word for it. The food industry has tried the products and finds them to be an improved hygienic design from their point of view. If you'd like to find out more about hygienic design tools, there are a number of publications available. We have a couple of articles in New Food and International Food Hygiene. We have a published paper in the Journal of Hygienic Engineering and Design, published in 2015. We just had a book chapter published in the EHEDG Handbook of Hygiene Control in the Food Industry. And you can always visit our website or contact myself for further information. Okay, and I think that then takes us to the Q&A session, so thank you very much.
Thank you, Deb. And again, this is Deb Smith, Global Hygiene Specialist at Vikan. I mispronounced that earlier, but thanks so much. I think we have a few questions. Some of you apparently have already discovered the Ask a Question box in the middle left of your screen, but you still may be able to type in a question there, and we will attempt to answer it. Here's a question that has already come through. Are there technologies out there that can eliminate bacteria by way of using a light source? My thought is light can reach difficult areas.
Yeah, no, actually that's a great question. And there are some, I suppose unfortunately they're still at the development stage. So there's UV light. You can use UV light to actually kill surface bacteria. There's also the use of things called cold plasma or pulsed light. They're two other options. The biggest problem is, although you're quite right that light can reach difficult areas, if in any way an area is shadowed by something else, then the light doesn't get to it, and that can be the issue. So you're great if you've got a nice flat surface. The UV or the pulse light can do a very good job at decontaminating that. But as soon as you have areas that get shadowed, or in between bristles, for instance, is always a tricky one, or even a badly pitted surface, then the light can't penetrate enough to give a good decontamination effect. There have been a lot of studies done with nice flat surfaces and say very effective, but as soon as you get any kind of complex geometries, it starts to get more tricky.
Very interesting. Another question is, how do I know which equipment is most suitable for use in my production application? Does it all have to be of good hygienic design?
Yeah, that's a good question as well. And I'm afraid that there's no simple answer. It's pretty much down to doing a risk assessment. So you have to look at your process and your production, what kind of food you're producing and what the risks are associated with that food. If you've got high-risk food where you're dealing with allergens, or it's a ready-to-eat food where you've got no further processing of the food before it gets to the consumer, then I would say that you would really want to focus on hygienic design throughout production, not just in your cleaning equipment, but everywhere. Because everything you can do to minimize the risk of cross-contamination is going to be important. If you're dealing with raw fruit and vegetables or dry, maybe non-allergenic products, then maybe you don't need such a high level of hygienic design in your cleaning equipment. You know, drilled and staple brushes have done a very good job for many, many years, and we're not advocating everybody throwing away drills and staples and going on to ultra-hygienic design equipment. But where it's necessary in those high-risk environments, and you've done a risk assessment to determine that, then hygienically designed equipment is a good bet.
And there's a question that segues into this. the hygienic design of other cleaning equipment, are there issues with these too, and are there any hygienic alternatives?
Well, as you saw from the investigations we did with the brushware, there are hygienic design issues, particularly with brushware, and even the most hygienic, or the ones that were felt to be the most hygienic, the resin set brushes, do have some hygienic, actually classic hygienic design issues. I think hygienic design awareness is increasing within food equipment manufacturers, but really Vikan have been pioneering this through EHEDG, and we have a range of equipment, the ultra hygienic range, which includes squeegees and brushes and handles, where we've tried to employ hygienic design principles to minimise the risk of cross-contamination.
And Deb, what are some of the most common types of assessment procedures in the United States? Are those that you had explained in terms of hygienics, were those common? Is the UV gel assessment method widely used here?
No, in fact, the methods that we've shown you today are all ones that Vikan have kind of nicked off of from other things. So the UV gel is mainly used for cleaning validation of hands. The protein solution one is for cleaning validation of surgical equipment. To my knowledge, nobody else has ever used those in anger to look at the hygienic design or the cleanability of cleaning equipment. They are just techniques that I knew about through my previous work with the Research Institute and thought would be appropriate as a way of investigating hygienic design of cleaning equipment. Mm-hmm. And I think that's why we really need some kind of guidance. How is it that people can go out and determine what's hygienic and how is equipment hygienically designed? Visual inspection is fine if you know what you're looking for, but are there more measurable methods that can be employed?
Thank you very much. And another person asked about whether you have any electron microscope images as you did for the other brushes. Are any of those
for the UST brush?
Yes.
No, we don't. The reason was that we actually did the original investigations about 3 years before the UST brush was finalised. So the study as a whole spanned about 5 years, and we started off by investigating what was currently on the market, and then based on the investigations, we then developed the UST. We have had some other investigations done with the UST, which involve a CT scanner, where we actually look at the integrity of the whole brush by passing it through a CT scanner. But that information at the moment is confidential because we're hoping to get that published somewhere.
Very interesting. Again, we are talking about cleaning tools, and are your cleaning tools hygienically designed? That's really all the time we have today. We will be sending you an email shortly with instructions on how to download the slides from today's webinar. We will also let you know when this webinar is available for on-demand viewing, probably within 24 hours. And the next screen will be an exit survey we hope you will take. That will do it for us. Deb Smith, Global Hygiene Specialist at Vikan, thank you so much. This webinar is over. Thank you all for tuning in today.
Thank you, Lauren.